Hello, good morning. My name is Katherine Chen, the Director of Business Development for the Hong Kong Research Institute of Textiles and Apparel. Today, I'd like to introduce some of our technologies in R&D specifically for the denim industry. This is our first time, and we are very honored and happy to participate at the Tripping Blue 23. This is our first time to join this excellent event. It's very innovative and design-driven, but we are glad to be invited to share some of our developments for the participants and also all of you in the denim industry. So let me introduce our research center for your understanding who we are and what we do. We are the research center specifically doing R&D work for textile and apparel, and we were established in 2006. And we are the only R&D center funded by the Innovation and Technology Commission of the Hong Kong government, doing just for textile and apparel research and development. We aim to be the leading center of excellence in research development as well as technology transfer in the global fashion industry. Housed in Hong Kong, our presences are located in multiple locations, including offices, laboratories, pilot plants, as well as retail operations for all our research and development projects. And over the years, we have won over 100 awards in different innovations, R&Ds, as well as design from global organizers such as Geneva's Inventions, Red Dot Designs, R&D 100, Fast Company's Global Changes Ideas, as well as Edison Awards. As an R&D center, we work very, very closely with our local government for R&D project fundings. We also work closely with different professors and scientists in universities from around the world. And of course, we work closely with different industry stakeholders from manufacturers, brands, and retailers, as well as startups who are also looking into new inventions and innovations for the textile and apparel industries. We work not only with the local entities, but also anyone in the world. We have worked with different companies and individuals in Asia, in Europe, in the Americas as well. All of our research projects carries at least one of these three themes, being sustainability, industry advantage, and social benefits. And now, let me start to introduce some of our prime technologies covering circularity of textiles and apparel, which is a very, very important topic for the fashion industry nowadays. The first step in recycling is, of course, the garment sorting, especially for post-consumer garments that consist of multiple varieties of colors, compositions, and also garment types. We have done a sorting system based on hyperspectrum cameras as well as AI to identify 4 different categories which are essential for recycling, which are garment type, textile structure, compositions, as well as colors. We have built a database of over 20,000 garments of different types, compositions, and color in our studies in the month times. And we have achieved identification that takes only 1 second with accuracy of over 90%. This is a lot of work because we have used different garments that we have collected in the communities that consist of sweaters, shirts, of course, denim jeans, and many different kinds of garment types with different compositions and colors that can identify those garments by not needing to lay down by manual work, but only using an automatic robot arms to pick up a piece of garment, and the camera can read the garment type and also composition and color automatically. Next, this is a project that takes a wet processing to separate different blends of textile, focusing on cotton and polyester, which is the key and major blends that is being used in the textile world nowadays. So this is a separation process that takes heat and water to separate cotton and polyester blended materials, turning the cotton into cellulosic powder, and then we can recover the polyester fiber from the fiber form, and then we can do the mechanical recycling process to turn them into yarn and textile once again to do a to make sure the circularity works. The cellulosic powder from the cotton, actually, we have identified so far 3 applications, and I'll do further explanation in the next few slides. Some background of this separation system that we have developed since 2016. We have the first idea that was generated in 2016, and we worked with a group of experts from Japan who has been working in the textile manufacturing for decades, that help us to build this system behind in the background of this picture that is located in Hong Kong, that helped us to do a lot of different pilot studies to make sure the technology works, and also identify the parameters to ensure that we have achieved a separation system that works efficiently and effectively. And starting in 2018, this pilot plan started to work in Hong Kong for us. There are some photos of this actual pilot plan that helped us to do different projects, separating cotton and polyester blends in different textile materials using water and heat, and a green chemical that takes about 30 minutes to 2 hours for the separation process. And then on this picture in the lower right-hand corner are the outcome of the separations. You see the cotton is turned into a cellulose powder form, and then the polyester remained in fiber form that can be further processed for yarn making and textile making. We understand that for recycling, there might be mixture of different colors, and also a re-dye might be required. Before the re-dyeing, there might be decolorization required, and we also developed a process that can environmentally remove the dispersed dyes from the polyester fiber. And this process requires only one green chemical that can remove the dispersed dyes from polyester effectively in also a very short time. And since 2021, we have built an industrial scale separation process which can process the cotton and polyester separation, as well as the decoloring of PET in Indonesia. That is running production scale already since 2021. I mentioned about the cellulosic powder. There are 3 different applications, and now I can do some explanation what they are. First one, we take the cellulose powder and turning them from being hydrophilic to hydrophobic, and then applying on textile fabrics by a padding, drying, and curing process to give a durable water repellent finish. We have done trials on 100% cotton fabric as well as 100% synthetics, which both give very good durable repellent finish using just the fluorine-free cellulose powder and binder. And next, we have also tried using the cellulosic powder, cross-linking them and turning them into super absorbent polymer, which is a polymer that can absorb over 20 to 30 times of its weight of water. And we decided to use this super absorbent polymer in farming cotton. And we have done several trials in actual cotton farms in India that has proven by using the SAP during the planting period, the cotton plants gives higher yield than the ones without using the SAP by over 30%. So this is a very proving and efficient and effective additives that can be used in helping to increase the cotton fiber yield in natural cotton farming. And lastly, those cotton cellulosic powder can be used as a feedstock for cellulose composite fiber making. We have been working on a project that's adding this cellulosic powder, which is recycled from cotton material into this cellulosic composite fiber, and also by adding different function to give multiple performance in this single yarn. Next, we all know that in denim, there are always nowadays a lot of the denim that takes actually a little bit of stretch fiber to give comfort when wearing the jeans, especially the very tight ones. And however, the elastomeric fiber in the fabric actually adds some complications in the recycling system. So we have developed a system using a biosolvent to remove the stretch yarn in the textile. And in this technology, using only a biosolvent to dissolve the spandex or lycra yarn in a fabric, it works very efficiently. Here are some results. So we have done different materials containing polyester and spandex, nylon and spandex, as well as cotton and spandex. We were successfully we were able to remove 100% of the spandex, remaining the only the polyester, nylon, or cotton in the fabric. And I think this is a very important technology that would require a successful recycling process for the next steps. Next, another specific project that is designed for denim fabrics are a separation of the warp and weft yarn of denim. We all know that the special construction of denim fabrics consists of the warp and weft in different colors. Usually, the warp yarn is indigo dyed, and then the weft yarn is undyed cotton. By separating them, we can help to save a lot of energy, water, and different resources if we can recycle only the indigo yarn for the indigo yarn processes, and then the undyed yarn for another different type of recycling process. So this project actually has a design consists of a specific mechanical work to separate the warped and weft yarn separately in high speed. Then we can help to reduce different resources in the textile making. Next, specifically also for denim materials are a water treatment technology. We all know that indigo dyes, it's very difficult to remove. And then no matter how long time or how much process is made, sometimes there are still indigo dyes remained in the wastewater. So we have studied and identified a group of macroalgae that is successfully removing the indigo dyes remained in the last stage of wastewater plant. It takes only 24 hours to complete the work. So this is a family of different macroalgae that does the work. It is a very green and energy-saving technology to do the removal of indigo dyes in the wastewater stream. And we talked about the circularity and also wastewater treatment in for denim. I also like to introduce another project that we have done specifically for cotton, is using the hydroponic farming system to farm extra long staple fiber cotton. We have a design that can process or farm the cotton using a hydroponic farming system, using solar panel that is definitely a renewable energy, and also natural sunlight, and also using LED lighting as a supplementary light source to help to control and condition the growth of the cotton plant. And our design works in a 40 feet container that can be located in anywhere and anytime. We can grow the cotton farm without needing the really harsh condition that the normal ELS cotton requires. And in our studies, we have done quite successful results using different lightings and also air condition to help to design and figure out what is the best condition for the ELS cotton to grow successfully. And we are trying to see if we are trying to reduce the length of the crop season so that we can increase the number of crops in a year to help improving the yield of the ELS cotton, which is a better quality and that gives better handle and a better design of the denim for the consumers. So thank you very much. And this is all of our technologies that I'd like to introduce to all of you. You can find more of our projects on our website, and also you can see us in different social media as well as podcasts. We share our latest innovations and also expert talks on all these channels. And hope to connect with you soon in person or online in the future. Take care and see you soon.